Welcome everyone. This is Math 105 and we're starting the study of statistics. And we're going to look at percentile, 5-number summary, and box plots. We're going to start off with percentile. So in statistics, we study sets of data. And what the percentile does is it divides that data set into 100 equal groups. We start at the lowest, and then the first percentile is 1% into the range of the data set. Second percentile is 2% in. Each one of these represents 1%. And we can go all the way out to P98, that's 98% of the way in, 99, and finally the highest data point here. So breaking up an entire range of values into 100 equal portions. So the definition, the formal definition, is if approximately some percent, 10%, let's say 25% or something like that, of all the data values in the set are less than some number x, that means x is the nth percentile. So let's say n is 25 for the 25th percentile, and x is 10. That means the value 10 is in the 25th percentile. And that means that 25% of all the data values are less than 10. And we're going to look at a real data set, and we're going to probably have a better idea of what this all means when we start actually analyzing the data set. So a couple applications of percentile, standardized tests. You may have seen this before. Let's say you want to know when you get your SAT score, where you fit in the range of all SAT scores. Well, percentile is one way to do that. And then in the medical field, we've also got examples from there. We're going to see a couple of examples right now. So first thing I want to do is make sure we can interpret what these percentiles mean. So here's one from the medical field. Sam's resting heart rate, RHR, Sam's resting heart rate is at the 15th percentile. So what does this mean? That means out of all the resting heart rates that were measured at, let's say, a particular hospital, Sam's resting heart rate is greater than 15% of all the resting heart rates, which means 15% of all the resting heart rates measured are less than Sam's. Now, since 100% is the total, that means 85% of all resting heart rates measured are going to be greater than Sam's. All right, your turn. Interpret this. Barbara's SAT score is at the 90th percentile. So if Barbara's SAT score is at the 90th percentile, that means she scored better than 90% of people who took the SAT. And that means 10% scored higher than Barbara. All right, now we're going to take a look at a raw data set. And we're going to calculate some percentiles. We're going to find some values associated with certain percentiles. Once we do that, we're going to be able to find exactly where certain data values fit inside of a data set. So first thing we're going to do is arrange all the values in descending order. That means from lowest to highest. So what I'm writing down are some scores on an exam for a math class. So here's our 30 values. Couldn't quite fit them across the top, so I had to go down the corner there. So these are all in order. All right, now what we are going to do with this data set is we're going to find the value corresponding to a percentile. So we're taking a percentile, plugging in the formula, and getting a value. Well, not actually a value, an index that's going to point us to a value. Where I is the index, and that's the position in the data set. So the first value is position 1, 2, 3, 4, 5. All right, that's the index. Now K is the percentile. That's where we'd be given. I don't know why they use K for percentiles, probably German or something. N is the number of values in the data set. So if we plug in the number of values and the percentile, we're going to get a number. And that tells us which position in the data set this value is. So let's give this a try. All right, we're going to find the 40th percentile. So that means out of this data set, we have 30 values, so n equals 30, and we're finding the 40th percentile, so k is 40. So we'll plug these into this formula, and we'll find the index. So that's 40 over 100 times 30 plus 1. So 40 over 100 times 31. So I equals 12.4. Now we didn't get an actual single value out of this. We got a decimal. So that means what we're going to need to do is round this both up and down. And we're going to find the values at the two closest positions. Round down to 12, up to 13. We're going to find the values at the 12th and 13th position. So we'll count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's 12, here's 13. So we have at 12th position, we have the number 74. At the 13th position, we have the number 75. Now we'll average these. So that makes the 40th percentile of this data set 74.5. So if you don't get an actual whole number here, you're going to need to find the two numbers closest to this one, position 12 and 13, and then average them. Now what this means is 40% of the scores in this data set are going to be less than 74.5, and 60% of the scores are greater. And that's the meaning of the 40th percentile. Your turn. Same data set. Find the 64th percentile. So plug it in 30 for n, just like last time. This time it's 64th percentile, so 64 for k. So we have 64 over 100 times 31. And that gives us 19.84. So we're going to look at the value in the 19th position and the 20th position. All right, the two positions closest to this number. Round down to 19, up to 20. So let's find the 19th and 20th position. So let's count backwards. 30, 29, 28, 22, 21, 20, and 19. Here's 19 and 20. 19 is 82. 20 is 84. If we average them, we get 83. So the 64th percentile of this data set is the number 83. And notice that the number does not have to be in the data set. 83 is not in this data set, but it's still a percentile from the way we calculate it. So that means 64% of the values are going to be less than 83, and 100 minus 64 is 36% of the values are going to be greater. All right, so this is the equation to go from percentile to value. Now we're going to go the other way, value to percentile. All right, to find a percentile, we're going to use this formula. So x is the number of values below the selected value. So let's say we wanted to find the percentile associated with 62. We would look at all the data values that are less than 62 and count them up. 1, 2, 3. So x would be 3 for 62. Y is the number of times the selected value appears in the set. So let's take a look at number 70 at 72. All right, we have 3 different 72s in the set. So y would be 3 if we were picking 72. Now, if we pick 72 and we want to find the number of values below the selected value, you want to find the number of values below the leftmost selected value. So start here on the left and then count. We would count 1, 2, 3, 4, 5, 6, 7. So if the selected value is 72, x would be 7, and y would be 3, because there are 3 72s. And just like last time is the total number of values. So we're going to do an example of this one, and we're going to find the percentile associated with the value 70. All right, here is 70. So let's count down from 70. 1, 2, 3, 4, 5, 6. 6 values below 70. Do not count 70 itself. So that gives us an x of 6. And now the number of times 70 appears, that's just 1. So y equals 1. And just like before, same data set, so n equals 30. All right, let's plug these in and see what we get. P equals 6 plus 0.5 times 1 over 30 times 100. And we get 21.7. Now with percentiles, all you have to do is round. And this rounds up to 22. So the percentile for 70 is 22. Another way of saying that, 70 is the 22nd percentile. Your turn. Find the percentile for 82. All right, here's 82 with the leftmost one. Now we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17 values below 82. So x is 17. There are 2 82s, so y is 2. And there's still 30 values. See, 17 plus 0.5 times 2, this is 1, so that's going to be 18 over 30 times 100. And that gives us 60. So that makes 82 the 60th percentile of this data set. And so maybe we don't want to break the whole data set up into 100 equal parts. Maybe that's just too many parts. So there are some special percentiles that we can use to break the data set up into larger pieces. Maybe for more meta-analysis. So we can take a data set just like we did before. And here we got the lowest value. So we got the lowest value, the highest value, and we're going to break it up into quarters. So we got 4 quarters. Here's 25% of the data values, another 25%, each one of these 25%. And so these special percentiles are called quartiles, for like quarter, breaking things up into 4. So here's the first quartile, second quartile, third quartile. And the second quartile is a special name. It's called a median. So that's something you're going to need to know for sure. It's a very important one. All right, so now we're going to use a procedure to find each of these quartiles. Now the median is the middle value of the data set. Now it's easy to find if you have an odd number of values because then it's just one value. We just look at the middle one. In this case, we have an even number of values. So if we start at the outside and start counting in to find the middle, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here's 15, and here's 16. So we have 14 values up to here, and then we got another 14 over here. So that means our middle is made up of 2 values. All right, so we're going to find, if we have an even number, we're going to find those 2 values, and we are going to average them. So 78 and 79. Then average those 2 together, and we get 78.5. So for this data set, the median is 78.5. All right, now we know where the middle is. It's right here in between these 2 values. So now we've broken up the data set into 2 halves. And the middle is right here at 78.5. So now what we're going to do to find Q1 is to do what we just did, except just for the first half. So now we're going to look at from here to here, from 44 to 78. Now let's find the middle value. We're going to find the median of the first half, and that's Q1. All right. So it's not the median of the whole data set. Median of the whole data set we already found. Now we're going to find the middle of this one. So we've got 15 values. So that means we actually have one single middle value. 1, 2, 3, 4, 5, 6, 7. And here's the middle. And 1, 2, 3, 4, 5, 6, 7. So the exact middle is at 72. So that makes Q1 72. Now we'll do the same thing over here to find Q3. We're going to look at the second half of the data set. 1, 2, 3, 4, 5, 6, 7. And here's the middle at 88. And then 1, 2, 3, 4, 5, 6, 7. So 88 is the middle. And Q3 equals 88. And there are 3 quartiles. All right, your turn. Now there's a different data set you'll be working on. So get that off of either the PowerPoint or the PDF. It's the one where we start at 12. It goes 12, 18, 22, 23, all the way up to 132. All right, so here's some highlights from this data set. start at 12, first row out to 53, then we go 60, 91, 93 to 132. Now in the middle row, the two middle values are 72 and 78. So this is value 14 and 15. No, sorry, 15 and 16. So these are the two middle ones. So we're going to average these two together, and that gives us 75. So the median, or Q2, is 75. So now we have to look at the first half of the data set. And there are 15 values, and the middle value is 40. So that makes Q1 40. And if you look at the second half of the data set, from 78 to 132, the middle value there is 100. So Q3 is 100. And so 75% of the values are below 100, 25% of the values are above 100. Half the values are above 75, half the values are below 75. 75% of the values are above 40, 45% of the values are below 40. And now we're going to create box plots out of the 5-number summary. So the 5-number summary for a data set are the three things we just found. Just found Q1, Q2, Q3, and also the lowest and the highest value. And then we can create a graph out of that that gives a very good picture all at once about what is happening with that data set. And these are pretty popular to use to give a little snapshot picture of what's going on. So a box plot looks like this. And these will have different sizes to them in different areas. So it could look something like that. And so the 5-number summary goes on this plot. Now you're going to have a number line below with values on it. And then we're going to line up the values in the data set so that they fit on the graph. So let's say, we've got some numbers down here. And then we know that the largest value in the data set is 53, so we're going to line up this thing right here at 53. And the end of this line represents the highest number. That goes right below that, where that line is. Now here, edge of the block is going to be the 3 quartiles. So here we have Q3. The median is at the dot of the line, so that's Q2, and Q1 is at this end. Now, there's one other thing that we can calculate, and that's called the interquartile range. And that is the difference between Q3 and Q1. Take Q3 and subtract Q1. And this is abbreviated IQR for interquartile range. And that just gives us an indication of the spread between Q3 and Q1. And then finally, the 5th number is the lowest value in the data set, and that goes right here at the end. So in this data set, the lowest value would be around 15. And then Q1 would be around 28. Q2, maybe 32, Q3 at 45, highest number 53, something like that. All right, and that is how you create a box plot. So we find the 5-number summary, create the scale, make sure that this number line is large enough to include the lowest number and the highest number, then everything else will fit. Alright, so I'm going to create a box plot out of our data set. So we know what the lowest value is, 44. We found Q1 to be 72. We found Q2 to be 78.5. Q3 to be 88. And the highest is 100. All right, so create the scale first. And since this is data from an exam, it makes sense to start at 0. But you don't have to. We could start at like 40 and it would all fit. Alright, so there's our scale, 0 to 100. Lowest value is at 44, so I'm going to find 44 and then start, the line's going to start there. Highest value is at 100, so other edge of the line is going to be there. So there's our endpoints. Q1, 72. So somewhere around in here, and the line will extend out to the lowest value. 72 to 78.5, so right around in here, we're going to create the box. And that goes up to 88. The box will extend up to Q3 at 88. So usually what I do is I'll just draw the box first, using Q1 and Q3, and then draw in the median at 78.5, so right around here. And then finish the line out to 100. And there's the box plot for our data set. Like I said, you can look at this and then very quickly get a picture for what's going on in the data set. And then lastly, to find the interquartile range, the IQR, that's Q3 minus Q1, and it gives us 88 minus 72. So the IQR is 16. And that is it for today. Hope you have a great day.